So let's get started. The first question we have is iron plus water gives Fe3O4 plus H2. Objective of balancing is to ensure that on either side of the equation we have same number of each element. Like for example, when I say Fe, it means there is one iron here. Okay, but on this side we have three iron. Same oxygen, this side we have one, this side we have four. And hydrogen is to both the sides. So we need to balance hydrogen, iron, and oxygen on either side. So the number of element on each side must be same. That's the whole objective of balancing. Now here there is no hard and fast rule. We just need to put to trial and error. There can be some precedents which we can establish, but there is again no hard and fast rule. So first thing is let's try to balance metal. What is the metal here? Iron. So this side we
Iron.
have three iron, and this side we have one iron. So we can balance this by putting a 3 over there. So now iron is balanced. Next, oxygen this side is 4, and this side we just have 1.
One.
So we can balance this by putting a 4 over here. Okay, finally, H2 needs to be balanced. How many H on the left side?
8.
8H. So in order to balance that 8H, we can put a 4 here.
Yes.
Okay, so next one, who would like to tell? Maybe the first few, whoever wants to tell can try.
Sir, can I tell?
Yes, please.
Okay. Sir, it's very simple. You just add a 3 in front of Ca, calcium.
Okay, so this is simple. So just put a 3 in front of calcium. So calcium gets balanced, nitrogen gets balanced. Done.
Yes, sir.
Next equation. All right, Vanshika, will you like to try this one?
Yes, sir. Do you put a 2 in front of KOH?
Yeah, we can. So that K gets balanced. Zinc, I think, is
And put,
already balanced.
yes.
Hydrogen also got balanced. Even oxygen got balanced. Oh, wow, that was easy. Okay, a single substitution made so much of a difference. Okay,
Do you add 2 Fe?
for the next one.
Yeah.
Okay, let's try. If I put 2 Fe, iron gets balanced, but oxygen is not balanced yet. Carbon is already balanced,
Yeah.
but
Oxygen.
iron is not balanced yet. How do we balance iron? Sorry, iron is balanced. The oxygen is not balanced.
Will become 4, no?
For where?
O3 plus there's one more CO.
Sir, do you put 3 in front of carbon dioxide and CO?
That's actually a good step. Okay, let me also explain you like the thought process. Okay, I don't know how Vanshika did it. Maybe through trial and errors he got it. But let me just explain you what I am thinking. So see here you have two iron. So here also we got like we made two iron. That step was fine, no problem. Carbon is already balanced, so 1 and 1, no problem. Okay, problem starts with the oxygen. Now here we have oxygen and here also we have oxygen. But when I observe closely, I realize that this has one oxygen with carbon and this has two oxygen with carbon. So in this case, oxygen is double. Okay. Now we have some extra oxygen here, like three extra oxygen here. Now the thing is, if I put some number here, I need to put the same number here. Like if I put a 2 here, I need to put the same number here so that carbon does not get disturbed. Correct? We won't like to disturb carbon because if I put a different number, carbon gets disturbed. So what I thought is, see this here we have three oxygen. If I put 3 like here, oxygen will become 3 plus 3, 6. And if I put 3 here also, it would become 3 twos are 6. So since 3 oxygen were outside, I thought let's put 3 carbon monoxide and 3 carbon dioxide. So that carbon also remain balanced and oxygen this side is double than this oxygen. Okay. Are you understanding my point?
Oxygen then will turn 6. 3 twos are 6.
Yes, that's true. Like here it becomes 3 twos are 6.
Mhm.
Here. And this side we have 3 oxygen and 3 from here.
Okay. 3 plus 3. Okay, fine.
3 plus 3, 6. So that was the idea behind putting number 3. Now, this what I did in this particular example is not some rule. It's more like experience, like trial and error experience that, oh, this can be done. Correct? Let's see the next question. Okay, sorry. I just
Sir, can I tell? Sir, can I tell? Please, please, please.
who is that?
Sir, me.
Sneha.
Snake. Yes. Sir, can I also tell? Sir, it's 2 and 3 and you add 3 H2O.
So 3 PbO, 2 NH3, 3 Pb, and 3 H2O.
Okay, so 3 PbO, 3 NH3 or 2 NH3? Can you repeat, please, Yashashvi? It's 3, 2, 3, and
3 and 3.
3 and 3 for nitrogen. No, 3 for water.
Nitrogen has nothing.
Nitrogen has nothing. Okay.
Sir, I did one more and I didn't get it.
You did not get this, sir.
No, sir. I put 2 in front of PBO. Then I didn't do
Okay.
anything to ammonia. I put 2 in front of PB and 3H2 only.
And you even that is balanced?
Yes, sir. I think so.
I don't think so. Let's check your answer. So you said 2 in front of PBO,
Yes, sir.
2 with PB,
Yes.
then ammonia.
No, ammonia I didn't put because it gets balanced when I put 3 in front of H2O.
Okay. But the hydrogen gets disturbed. So we need to put a 2 back here.
Okay.
But you see, oxygen is not balanced. Here we have 3 oxygen, here we have 2 oxygen.
Yes, sir.
Okay. Let me show you step by step how I will try to balance. So PB is 1 on either side. It is balanced. Okay. First, try to balance the metal. Now with PB, here we have a O, right? With the metal, see what is there first. With this side, we can see it's a O. So let's try to balance O. Okay. O is already balanced. Now with O, what is there? H2. Okay. So let's try to balance H2. This side we have 2 hydrogen, and this side we have 3 hydrogen. Okay. We can't balance that 2 and 3. So only option left is we multiply this with 3 and this with 2, because 3 twos are and 2 threes are is 6. Then here we need to work backwards. Okay, backwards means in the while balancing hydrogen we disturbed oxygen. Oxygen became 3 here, so we need to put 3 here, and to balance lead we put a 3 here. Okay, I started with metal, lead, I balanced it, then oxygen, then I tried balancing hydrogen because it was with oxygen, but while balancing hydrogen, oxygen got disturbed, so I went backwards and then balanced oxygen and lead again. Now this is all balanced and nitrogen automatically got balanced. Hopefully it's fine. See, yes. Last year, can you explain me how to do the F question?
So I'm getting stuck.
Can you explain me where you're getting stuck?
Like PB is PB. In front of PB you put 3. PBO
Okay,
you put 3.
okay, let's do that. Yeah, yes, that's fine. What do we do
And then
next?
O also changes to 3.
O also changes to 3. Okay, so PB is balanced and only O is there, so fine. So 3 oxygen is here, okay? And this side, how many oxygen are there on the left
2.
side?
2.
4. Left side,
Oh,
left
that
side.
oh,
On the
4.
reactant side. Reactant side,
Oh,
we have 4 oxygen, right?
yes.
Okay, now what is your concern?
No, 3 plus 2 gives 6,
5.
right? Because it's
5.
1 more row.
3 plus 2 gives 5.
5. 5, 5.
Okay. These 4 oxygen, they are connected with lead. Even this oxygen here is connected with lead, and 3 of them. So if I change these oxygen number, okay, even lead will get affected. And therefore these oxygens are not my best friend. Okay. But I can always manipulate this oxygen because it's alone. Okay. I needed a 1 here. Wouldn't it be better if I get a 1 here instead of 2? Like that's the major problem here. Like why is it 2? Can't it be just alone 1?
Yes.
Isn't it? Okay. If I somehow make this 1, will that balance the chemical equation? You know how we do that?
O2 will become O.
No. Put a half here. What is half
Half.
into 2?
1.
1. So this become 1. But can I leave my equation like this? No, it is not allowed. You cannot leave it in fraction. So
No.
just for this step, put a half, because if you come across this situation where you're getting an odd number and you don't know how to make O2 odd. So for such situation, this is the tool. You can just put a half here. Suppose we needed a 3, right? We would have put we could have put 3 by 2. Okay, so same thing. If I needed for a 5, I could have put 5 by 2. Since I need just a 2, just a 1, I can put 1 by 2. So now to get rid of this fraction 2, we multiply the whole equation with 2. So 3 2s are 6 and half into 2. So 2 gets cancelled. So this is my final equation. 4 plus 6 PBO plus O2. Understood? Okay. So when we do this, like suppose we are left with one single element which is given in pair and we need it in odd numbers. Correct? Okay. G1. Who would like to explain? Yes, Yashashvi, you wanna try this one?
Yes, sir.
Yeah, please tell me.
So 2 PBS
Okay, 2 PBS.
and then 3 O2,
Yes,
2 PBO and plus 2 SO2.
2 SO2. I think it's this is also correct here. Okay, can I just quickly explain you the way I did the previous question? So we start with the metal PB. It is balanced on either side, so that's that's okay. We can ignore it. Now with now we can move to sulfur. Sulfur 1 1. It is balanced. Okay, so why we were trying to balance sulfur first? Because sulfur is lesser in number. Oxygen is distributed everywhere. So last we go to oxygen. Okay, in most of the reactions, you'll find that you're either balancing oxygen or hydrogen at the end. Okay, again, there is no hard and fast rule. So let's try to balance oxygen now. Okay, this side, how many oxygens are there on the right side? 2 plus 1, 3. But here we have 2 oxygen. You remember how we deal with this situation? Put 3 by 2 and then multiply the whole equation with 2. Am I clear? Let's see the next question. H, who will like to tell H?
Sami.
Okay, Vanchika, please tell.
So 2 H2SO4, then 3 SO2, and 2 H2O.
2 H2O, okay. So 2 and 3, sulfur is balanced. H2 is balanced. Yeah, it's balanced. Yeah, Sneha, it's your turn, I think.
So you would add 6 HNO3, then 6 NO2, and 2 H2O.
Okay, that's fine. That's balanced. Yeah, anyone explaining the J1?
So can I?
Yes, please.
Okay. HCl,
4 HCl,
2 H2O.
2 H2O. Okay, good.
That's it.
That's it. Chlorine is already balanced. Yeah, it got balanced. Hydrogen is balanced. Oxygen is also balanced. Yeah, it's it. Okay, here we have a very interesting question for you. Based on whatever we have learned in the first part, element X and Y, X, Y, and Z have 3, 7, and 6 electron in the valence shell. Write the formula of the compound formed between X and Y and X and Z. How do we do these type of questions? Any idea?
So you find the electronic configuration, I think.
Electronic configuration is not required because the like 3, 7, and 6 is not what you call, they are not the atomic number, they are directly the valence electron. So since we already know the valence electrons means the number of electron in the outermost cell. Okay, so from that we can directly predict the valency. If they had given us atomic number, then we would have tried finding like the electronic configuration. But since in this question they have just given us the valence electron means number of electron in the outermost cell. So for X, valence electron is 6 or 3. X is 3. So can you tell what is its valency, or what would be its valency?
So
It
3
has
plus.
3 electron in the outermost cell. So it's 3 plus, right?
Yes, sir.
And what about element Y? Y has 7 electron in the outermost cell. Then what's its valency?
So 1 minus.
Minus 1. Very good. And Z has 6 electron in the outermost cell. Therefore, what is valency of Z?
2 minus.
Minus 2. Now, see, this mean I can write X as X with a plus 3 sign, like in cation form, and I can write Y as Y minus. Now, we don't know what is the actual symbol of X and Y, and we don't even need to know that. We can just tell the answer in terms of X and Y. Now, what is the formula for compound formed between X and Y? I think we do the crisscross method. Therefore, what is the formula? X 3 plus and Y 1 minus. 1 comes here, 3
X
goes
by
there,
3.
so it is X,
XY3.
Y 3. I hope you understood the method, like how we do these type of questions. Can you similarly tell me the B1 then? I'll wait for your answer.
So you have to do the crisscross method and tell.
Yeah, yeah, obviously.
Sir, X2Z3.
X to Z3. So X with a 3 plus and Z with a 2 minus. Again, crisscross formula is X to Z3. Okay, so I hope you won't struggle with any question of this nature.
No.
Let's talk about the next topic. Molecular mass. Molecular mass of a substance is sum of the atomic mass of its constituent atom present in the molecule. Can you give me example of a molecule? Anyone?
Sir, oxygen, O2.
O2 is one molecule. Okay. Let's take more examples.
Sir, hydrogen and nitrogen.
Okay, I have three examples now, but all the molecules which are written on the screen, these are all elements. Can we have an example of a molecule which is a compound or a molecule of a compound?
Sir, is H2O a compound?
H2 a compound and
CO2.
CO2. These are compounds. Okay, suppose we want to write the molecular mass or we want to calculate molecular mass of O2. Okay, from the formula, it's quite clear that it consists of two atoms of oxygen and each oxygen is 16 AMU. So it is 16 plus 16, 32. I happen to remember this like over the period of time, you will also remember some of them. But it is not compulsory in ninth grade to remember these values. Okay, next element, hydrogen. There are two hydrogen atoms, each one of them is 1 AMU. So total mass is 2 AMU. What do you understand by AMU?
So atomic mass unit.
Atomic mass unit. So this is basically like used for measuring smaller quantities or smaller weights. Like for example, if we want to buy some fruits from the market, we weigh it in kilogram. If I want to buy some gold from the jewelry shop, I'll probably go by 1 gram, 2 gram, 5 grams in grams. Okay. Similarly, if you want to calculate mass of smaller entity like atoms, molecules, gram and kilogram is a very huge unit for them. Okay, so therefore we actually measure them in smaller unit of mass, which is atomic mass unit. Okay, similarly, nitrogen consists of two atoms, each having mass 14 AMU. So total mass is 28 grams. Similarly, okay, now we know hydrogen is 1 and and oxygen is 16. So what is mass of water? Can someone tell me what is
So
mass of water?
18 AMU.
How much, Anaya?
18. Oh, yeah, 18 AMU.
18 AMU. Because two hydrogen each is 1 and 1. Okay, and then one oxygen 16. So total is 18. Simple. Okay. Similarly for CO2. Okay, if you need carbon mass, carbon is 12. So can you help me calculate CO2?
So 74, I think.
No,
No, 76.
no.
Okay.
One carbon, two oxygen. It's one carbon and two oxygen.
So I accidentally multiplied it by 4.
So what about one carbon?
44. So
Yes,
is it 40?
yeah, 44 is correct. Go in a sequence. As you are ready with the first one, you can tell me the answer. Na2SO4 dot 10H2O.
So what does that dot mean? Multiplication.
No. See, Na2SO4, just think as an independent molecule, calculate the mass. Now, what about this 10H2O? H2O means water. 10H2O means 10 water.
Okay.
So 1 Na2SO4 plus 10 water.
Okay. Fine.
So I think I got the first answer.
Yes, please tell.
So 178.
Yeah, I'm very fine. 178. Others can also tell their
Yes,
answer.
sir.
You can try the next. Meanwhile, others can also check and tell their answer so that I will confirm you. You
So
want to tell
I'm
the
not
answer?
getting, sir,
Not
I'm
getting.
not getting the first one, but I got the second one. I think
Okay.
it's 96, if I'm not wrong.
Okay.
But
96.
yeah, somehow got 96 for the second one.
I got 96 for the second one.
No, not that one, not that one, the second one.
Oh, okay. Okay. Sorry.
Yeah, the second one is 96. But the first one, I'm totally confused. I don't know how is it so.
Sir, I did the third one.
So me too.
So me too.
Third one was the answer.
So
60.
60.
That's
You can
60.
you can all tell your answer, then we will verify at the end. If anyone has a different answer, they can also say. This was 176. Anaya, what did you get? 176.
178.
So
So
that
is
was.
the first one 100?
I'll write 100 for now. Then we'll start verification.
Yeah, okay.
So the fourth one is 100.
Fourth one 100. Okay. So yeah, let's start with the first one. See, first one, we have 2 sodium. 1 sodium is 23, so 2 sodium is 23 into 2. Plus 1 sulfur. 1 sulfur is 32. Plus 4 oxygen. That means 16 into 4. Okay, plus. Now here the like dot doesn't mean multiplication. It just means 10 water. Just on the previous page, we calculated water is 18. So it is 10 multiplied with 18. Okay, you can directly write it like this. Calculate for 1 water, multiply with 10. Am I clear? So this is 46 plus 32 plus 64 plus 180. Okay, so 64 plus 46 is 110.
So 332.
322 or
Yes, sir.
22,
Sorry,
not 30.
332.
Sir, I was right, but then she told 178, so I got confused
Yes,
and
sir, even I got confused. Even I got the same.
Even I got confused.
Oh, okay. And now you confused so many people there. Yeah.
Sorry, guys.
Okay. Okay. I think the others are more or less correct, so it's easy. Let's just okay. N is 14, 15, 16. 16 twos are 32. Okay. I'm just verifying the answers are directly 14 plus 16. Oh, sorry, 12 plus 16 rather. So yeah, 44. This is correct. Okay. Again, NH4, 14 plus 4, 18. 18 twos are 36 plus 12 plus 16 threes are 48. 60, 96. Yeah, this is correct. Okay, magnesium is 24. 24 into 3 is 72. N2 is 14. 14 twos are 28. So 100. Okay, I think that's simple. What is difference between an atom and a molecule and element and compound? Okay, so anyone who would like to try any one of them, like if you could just give me an idea, what is an element, what is a compound, or before that, what is an atom and a molecule, with an example. I hope you have all heard this name, right? It's not new. We have been learning definitions for atom, molecule, element, compound, but a lot of time we have confusion with this. Like, what is an element? What is a compound? What is an atom? What is a molecule? So this is the time to just clarify this.
sir, you just want us to tell an example.
Yeah,
And
that's all.
sir, I'm not sure for atom and molecule, but I'll try element and compound.
Okay.
Element is you can take helium He and compound water H2O.
Okay. So you say helium is an element
Yeah, He and
and
water
compound is
H2O.
water. All right. I think so. What we understand from this element is just one kind of atom. Compound is made up of multiple types of atom combined together. Correct. So element is just one type of atom and compound is multiple type of atom. See, element means one type of atom, like one type of element atom. Compound means when we have mixture of many types of atom combined together chemically. On the other hand, atom means just a single atom. Okay, an atom which is alone. Molecule means when atom combine, they form a molecule. So these are like single, alone, or atom when they are alone. Atom means atom when they are alone, we call them atom. And this is atom which is chemically combined. Okay, let's see some example. Like for example, suppose we have a box. In this box, we have helium atom. We all know that helium is monoatomic, means it stays alone. Like helium doesn't combine with other element, neither with itself. So it stays alone. So we can say that in this box, we have atoms of helium. Okay, at the same time, if someone says, what is the element present in the box? So we can say element is helium. Okay, suppose we have another box which consists of hydrogen molecule, H2, 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 H2. Now, in this case, every element, like every atom is paired up to form a molecule. Like hydrogen is not alone, it is in pair. So when atom combine with each other, with themselves or with anyone else, whenever atom combine, they form a molecule. So in this case, we can say that my box contains molecules of hydrogen. Okay, my box contains molecule of hydrogen. Inside the box we have one kind of atom or more than one kind of atom?
So one kind.
One kind. So is it element or compound inside the box? It's an element. So H2, though it is a molecule, it is an element. So we can therefore say that element inside the box is hydrogen. Okay, so you understood the difference? See, when the element is alone, we call them atom, but when the elements are combined, even to themselves, we call them molecule. Okay, now the third box contains gases like carbon dioxide. Now, in this case, every single species are like chemical combination of carbon and oxygen. So they are not alone. They are like carbon is combined with oxygen in each one of them, right? So this again is not an atom, but a molecule. So this is molecule of carbon dioxide. But in this case, since the molecule, every single molecule is made of different kind of atom, means every molecule has one carbon and two oxygen. This doesn't qualify to be an element, but rather it is a compound. So it's compound of carbon dioxide. Am I clear?
Yes, sir.
So just helium is atom of the element helium. Just H2 is molecule of the element H2. But just CO2, CO2, CO2 is molecule of the compound CO2. Now, percentage composition, it's just the extension of atomic molecular mass, which we learned earlier. Okay. So in percentage composition, we check like suppose a molecule consists of various elements. For simple example, could be H2O. H2O consists of two elements. One is hydrogen and one is oxygen. Okay. If I ask you what is percentage of hydrogen here or percentage of oxygen here, so how do we find percentage of hydrogen or oxygen? For that, what we do, we first calculate the total mass of H2O, which is 18 AMU. Okay, out of this 18 AMU, how much is hydrogen? 2 AMU.
2.
And what about oxygen?
16 AMU.
16 AMU. Now, percentage hydrogen would be 2 divided by total 18 into 100%. You can do the maths here. This goes 9 times and 100 by 9. And this is 16 divided by 18 multiplied with 100. Okay, you can do the maths and tell me the answer.
So the first one is 11.1%.
11.1%. Okay.
So the next one is 88.8%.
88.8. Okay, in this question is given, calculate the percentage of phosphorus in calcium hydrogen phosphate and in calcium phosphate.
So what are the atomic mass
Masses.
units?
Okay, I'll tell you the mass for each of these elements. So calcium here is 40, hydrogen is 1, phosphorus is 31, oxygen is 16, and yeah, I think that's it. Okay, so Tananya, in these kind of questions, we mainly find first mass for calcium hydrogen phosphate using that formula. So like from the formula, you can identify that it has one calcium, then H2PO4, the whole thing is 2 times, right?
Yes, sir.
So just you need to write like one calcium is what is mass of calcium? It's given on the right side. It's 40. So
Okay.
one calcium 40. Then H2, like one hydrogen is 1. So two hydrogen is 2. One phosphorus is 31. So plus 31. 4 oxygen is 16 into 464. And the whole thing is 2 times. So the whole thing multiplied with 2.
Okay, sir.
Okay. So like that, you need to first calculate mass of calcium hydrogen phosphate. Yeah, you were telling
Okay,
the
sir.
answers, Neha, that time.
No, sir, no, sir. I wasn't saying by mistake. I unmuted myself.
So at least you can first tell me the mass for calcium hydrogen phosphate. So let's start with that. Sneha, it's so easy. You were
I'll tell. I've done the second one though, fine, never mind.
okay.
Should I tell the second one?
Yeah, you can tell the mass, no problem.
I found 20% for the second one.
Okay, very good. That's fine. We'll check. We'll verify it.
So will the first one be 26?
26.5 is the correct answer. Okay, what is mass of calcium hydrogen phosphate? So calcium here is 40 plus. Then inside the bracket I'll write these like because they're two in number. So H2 every hydrogen is 1, so 2 hydrogen is 2, plus phosphorus is 31, plus 1 oxygen is 16, so 4 oxygen 64, whole multiplied with 2, because the entire thing is 2 times, and just we simplify this. So 40 plus, so 64 plus 31 plus 2, that is 95, 97, 97 into 2, 194. Okay, so the final answer is 234. Okay, this is calcium phosphate mass, calcium hydrogen phosphate mass. In this, mass of phosphorus is, okay, so we just need to look at this mass. 2 phosphorus are there, right? Phosphorus 2 times. So just phosphorus mass is 31 into 2, 62. Therefore, percentage phosphorus is mass of phosphorus divided by total mass multiplied with 100. Okay, and this is, as I think told by Vanshika,
Yes, sir.
26.5%. Okay, same I think Sneha calculated for B, which again I think is correct answer. 20% is also correct. So for the B part, accordingly Ca3PO4 whole twice. Okay, what is mass for calcium phosphate? Calcium 40, so 40 into 3, 120 plus 31 plus 4 oxygen 64 whole into 2. So this is 120 plus 60, 90, 95, 95 into 2, 190. So 310. Out of which phosphorus is again 2 phosphorus. So 31 into 2, 62.
62.
62.
And therefore, percentage phosphorus is 62 divided by 310
Into 100.
multiplied with 100.
Yeah. So if you simplify, you'll get 20%.
Yes, that's it.
Okay.
Okay.
Okay, sir.
Okay. I think that's fine for today then. See you later. Thank you and bye.
Thank you, sir.
Thank you, sir. Bye, sir.